Alrighty, here we go. We're going to record this synthetic division and hopefully, well, maybe you'll hear a bell, maybe you won't. I don't know. Let's see. But you're going to utilize synthetic division to divide polynomials. Yay! Okay, some of y'all are going to really like this and then they're going to be like, why, sir, why do you make us do long division? Because it's important. It helps you see things in a different way, okay? I realize that this will be something that y'all will probably find much easier, but it helps you see things in a different way. And to all be honest, synthetic division has a different reasoning for why we use it. Trust me, there'll be later when I can make that harder. All right, so let's look at this. It's really not too many examples. Okay, so let's take this type of problem, 2x cubed minus 13x squared plus something x, because I can't see right now because something's blocking my way, minus 24 over x minus 4. Now, let's start here. What you are going to focus on is the, first up, let's look. You got this little square thing here, and you're going to write the number that's in this parentheses, your divisor. What's the opposite of a minus 4? A positive 4. So you're going to put in there positive 4. Then you're going to take the coefficients of every single number, starting with the x cubed, so 2, negative 13, 26, I should have put positive 26, and negative 24. And there's the warning bell. Okay, and then put a line underneath. Now, in this space right here is going to be your remainder. And I'll talk about all the other numbers that you get first. So the first thing we do with synthetic division is bring down the very first number. So this 2 goes straight down right there. Then you're going to say 4 times 2. And that answer you're going to put under the 13. 4 times 2 is a positive 8. Negative 13 plus 8, there is no changing of signs. You just work with the numbers as they are written. Negative 13 plus 8 is negative 5. Then you will say 4 times 5, which is 20. Oh, I'm sorry, negative 5. So 4 times a negative 5 is negative 20. 26 minus 20 is positive 6. And positive 6 times a 4 is positive 24. And then you get 0. That is your remainder. Now, what happens here is this. If that is x cubed, that was 2x cubed, then the one under it is x squared. Like these always go down 1, so that's x squared. And mind you, this can only work if you have this as a singular binomial, like x minus 4, x plus 2, x minus 3, something like that. If it was like x squared, we couldn't do that. You'd have to go to long division. Anyways, okay, the next one is x, and they just work their way down. So if it starts at x squared, it's going to go x, number, and then remainder. So notice here, this was x cubed. This one is 1 less at x squared. It always works that way. Okay? So let's look at another problem. 3x cubed minus 8x squared plus 11x minus 14 divided by x minus 2. Okay, so notice here, the opposite of minus 2 is positive 2, and then I'm going to keep the signs for the ones in the second parentheses. So notice here, it was 3, negative 8, positive 11, negative 14. And again, under that negative 14 would become what's going to come is your remainder. So bring down 3. 3 times 2 is 6. 8, negative 8 plus 6 is negative 2. Negative 2 times 2 is negative 4. 11 minus 4 is 7. 7 times 2 is positive 14. Yeah, I probably should have put positive 14. I don't know exactly why I didn't put positive 14, but there you go. And then negative 14 plus 14 is 0. I'm not exactly sure why I didn't do that. Okay, so again, this was x cubed. This was x cubed, so that means this is going to be 3x squared minus 2x plus 7 with no remainder. So this is my answer. Okay. Wow, I should have really had some with remainders. It's really funny that these are coming out with no remainders. All right, so let's look at something like this. Here's one. If you notice, there are some missing pieces. Okay, so like we've got the negative 4. In front of the x to the 5th is a 1. After x to the 5th, there should have been x to the 4th, so put a 0. Then I've got the negative 4x cubed. Then I got the positive 4x squared. Then I should have had an x and a number. So notice here what I've got, that's what I should have had. So any of those are missing, I have to include them. All right, so kind of keep that in mind. So now I'm bringing down the 1. 1 times the negative 4 is negative 4. 0 plus negative 4 is negative 4. Negative 4 times... Wow, hold up here. I'm way off here. Negative 4 times... I was about to mess up there. Negative 4 times a negative 4 is positive 16. I don't know why I would put 8. I was really sleepy this morning. Okay, 16 minus 4 is 12. 12 times a negative 4 is negative 48. And that would give me negative 48 plus 4 is negative 44. And then I've got another 0 here. I'm running out of space. And this gives me 4 times 4 is 16, carry the 1, 176 positive. So that's 176. I ran out of space. And then that times negative 4, and this is because I was trying to make sure I changed this problem slightly from what I saw in the book. Oops. Negative 4 times 176 is 24, carry the 2, 30, carry the 3, negative 704. I hope I can multiply that right. I'm a little tired. Okay, so now this was x to the 5th, so this is x to the 4th, 1x to the 4th, minus 4x cubed, plus 12x squared, minus 44x, plus 176, minus 704. This is how I'm going to write the remainder, x plus 4. Okay, so notice how I put the remainder as a fraction over the divisor. Okay, there you go. So keep in mind that if you're missing pieces, you have to put those in. Okay, so what happens if there is a number in front of the x squared? We're going to skip that. Okay. No, wait. And I'm going to backtrack this a little bit. Okay, so you see here how this has a 3x plus 1. Well, I need to get rid of that 3 in front of the x. To do this type of problem, to do these types of problems, this always has to be like x plus or minus some number. Okay, always. So there should be no number in front of the x. So how do I get rid of this x? Well, I can divide it by 3. But whatever I do to the top or to the bottom, I'm going to do to the top. So I'm going to divide everything by 3. And that's what I end up with is x to the 4th minus 5/3 x cubed plus 1/3 x squared plus 7/3 x plus a 0 because I should still have that. And notice here I've got the 1/3. So this is what I'm going to work with. This right here is what I'm going to work with. Oh, happy joy, you have fractions. Yes, because you love fractions. Notice that it was positive 1/3, so I'm going to go the opposite of that, which is negative 1/3. It actually works out better than you think. So let's look. So I bring down the 1. Remember, that's still x cubed, and that's a number. Because I always have to go. If it goes x cubed, x squared, x. Wait. That's not x cubed. That's x to the 4th. Ah! I showed you too much of the work. Let's go back here. Okay, so that's not x cubed. That's actually x to the 4th. Oopsie. So then that would make that a number. And let's go from there. Okay, so that means bring down this 1. 1 times a negative 1/3 is negative 1/3. Negative 5/3 minus 1/3. On the Inspired, this is real easy. It should be easy for y'all anyway, but negative 5 plus negative 1 is negative 6. Negative 6/3 is negative 2. Negative 2 times 1/3 is going to be positive 2/3. That adds up to 1. This is negative 1/3. That adds up to 7 minus 1 is 6/3, which is 2. And this would be negative 2/3, which would go right here. That's your remainder. Okay, so if this is x to the 4th, this is going to be x cubed. Okay, so this is going to be x cubed minus 2x squared plus 1x plus 2. Now I'm going to put here plus negative 2/3 over x plus 1/3. Well, that looks really hard to comprehend with all those fractions, so let's multiply by 3 to get rid of the fractions there. So I would be left with x cubed minus 2x squared plus x plus 2. Negative 2/3 times 3 is negative 2, so plus negative 2 over, this would be 3 times x is 3x, 3 times 1/3 is 1, And there you go. That way you can kind of get rid of that ugly little fraction. Now, if you left it with that ugly little fraction, I'll probably still count it, right? But there you go. All right, that is synthetic division. So let's see how y'all understand this tomorrow. Hopefully y'all can show me a lot of good work. Thank you so much.